Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
Okay, so for this problem, you're going to use the graph that's given, which I approximately, and not very well to scale, drew in this upper left-hand corner here, in order to figure out each of the quantities. So the first quantity that you want to look at is the average rate of the reaction between 0 and 25 seconds. So the graph shows the concentration of Br2 as a function of time. So if you use this overall reaction, we can generate a rate expression. So right now we're only concerned with the concentration of Br2. So the rate is going to be equal to the negative change in the concentration of Br2 over the change in time. So this is all part A. So for 1, where we want to look at the average rate, so the rate average between 25 seconds and 0 seconds, minus 0 seconds. This is going to be now where you have the concentration of Br2 at time 2 minus the concentration of Br2 at time 1 is going to be on the top, and then you'll have T1 minus T2. Sorry, T2 minus T1 on the bottom of the expression. So this is going to be for your average rate. So if you look at your graph, and again, this is not drawn to scale. So let's say this is 25 seconds. You're going to find the point at 25 seconds and 0 seconds and figure out the concentrations. So if you use this graph, obviously not mine graph, but you get 0.75 at 25 seconds minus 1.0 at 0 seconds. And when you go ahead and multiply this out, you get a rate of 1.0 times 10 to the negative 2 molarity per second. Okay, so that's the average rate, and you can do this with any point. You just have to basically find the concentration that corresponds to the 2 time points on using your graph. So you can also use this graph to find your instantaneous rate of your reaction. So I will just call this INST for now. And so this is going to work a little bit differently. So for example, you want to find the instantaneous rate of the reaction, again, at 25 seconds. So the way that you're going to do this is you're going to go into your graph and you're going to draw a tangent line that's tangential to your point at 25 seconds. And using that line, you're going to find the slope. So you're going to pick essentially any 2 points on this line to figure out the slope, where you have the change in y, or the change in concentration over the change in time. And so I think the easiest way that you can typically do this is to draw it until it intersects the y-axis and the x-axis to figure out your change in concentration over change in time. So for example, if you go through, and again, my graph's not drawn to scale, but let's say you draw this line and your numbers may be slightly different from mine, but as long as they're relatively close, you should be okay. Because now your answers are going to be corresponding to how well you draw this tangent line. So for example, if you draw this line and you figure out that from 110 seconds to 0 seconds, you get a change from 0 to 1 concentration, and you go ahead and multiply this out, you get a rate of 9.1 times 10 to the negative 3 mole per second, which is close to the answer given in the book, which is 8.5. times 10 to the negative 3 molarity per second. And now we can do the same idea where we look at the rate, the instantaneous rate of the reaction, but now instead of looking at 25 seconds, we're interested in looking at 50 seconds. So same thing, you're going to draw a tangential line. And again, my graph is drawn really poorly. But when I did this, I got 0 minus 0.9 over 130 seconds and 0 seconds. And when you multiply this out, you get 6.9 times 10 to the negative 3 molarity per second. Now, the really important thing for this second problem is that this is talking about the concentration of Br2 over time. So the change in concentration of Br2 over the change in time. However, the question wants to look at the instantaneous rate of formation of HBr. So if we use this, we know that the negative change in Br2 over time is going to be equal to now plus 1/2 change in HBr over our change in time. So if we call this expression here x, now we can go and fill in our values. So we have negative 6.9 times 10 to the negative 3 molarity per second is going to be equal to 1/2 x. And if we multiply 1/2, or I guess multiply 2 to both sides of the equation, and this is actually a negative here, then what we get as our final answer is 1.38 times 10 to the negative 2 molarity per second, which is close to the answer that's given in the book of 1.3 times 10 to the negative 2. So again, your numbers might be slightly different. It just depends on how you draw your tangent line. So now the second part wants you to make a rough sketch of the curve representing the concentration of HBr as a function of time, assuming that the initial concentration of HBr is 0. So for example, if we look now on the left, you have Br2, which is our reactant, is going to decrease over time, giving this curve. We can look at the formation of our product, HBr, and assuming that at time 0, we have a concentration of 0, we can kind of just do a curve that would look like this. And so this is going to be our maximum point where it plateaus out is going to be around 2. So this would be our graph.